I just want to talk about the Hoover Lynx cordless vacuum battery. It is supposedly a 30 watt-hour lithium-ion 18-volt battery for the Hoover Lynx lithium-powered vacuum cleaner. Now, first I gotta say, this is one awesome vacuum. It's the best cordless vacuum I've ever used, in which I prefer because it's small enough for my younger son to use when he makes a oopsie. He gets to help clean it up, and he loves vacuuming. And I even wake up in the middle of the night, 4 a.m., and he's out in the hallway vacuuming. Why? I don't know, but he gets that from Granny. Anyways, of course, my vacuum's probably 4 years old now. It's getting a little aged, and battery doesn't quite last as long as it used to. I use it really drain it once a week, and then fully charge it up. Don't really let it sit fully charged. I usually use it a little bit just to bring that voltage down. Helps keep the cells last longer. But yesterday, I thought, why not see what the voltage of the battery is when the battery is dead? So that's what I did. Now, fully charged, they're dead at the point where the vacuum cuts off. The voltage of the battery was about 7.5 volts. I thought, that's not quite right. This is supposed to be a 18-volt battery pack. Now, obviously, when a battery is fully charged, the voltage level is going to be higher than when it's dead. That's just how batteries work. And there's also a nominal voltage. Now, most cordless batteries are advertised, or lithium batteries are advertised at their nominal voltage, such as my 20-volt Works cordless lawn implements, such as weed whacker, leaf blower, and whatnot, advertise 20 volts. Their nominal voltage is more around 18. Dead, they're about 16.5. Now, that would be what this actually should be reading, or close to it. So 7.5 volts was considerably lower than what it should have been. Now, that's the temperature probe to make sure the battery doesn't overheat during charging or discharge. And then positive and negative, which I got reverse, not that it really matters. Now, we're fully charged right now, and we're at 10.19 volts. And I assure you, that is correct. Now, let's open up this battery pack. And it uses a security bit, obviously. They don't want people to go opening these up. And these are actually extremely easy to rebuild if you know what you're doing. If you don't know how to handle lithium cells, please don't, because if you short one out, you're in trouble. Oops, that way. Because they have that stupid release mechanism. There you have it. That is 1, 2, 3, 4, 5 18650 lithium cells. Now, this is just a little bit odd that they're using 5. Let me just show you something. Anyways, this is an 18650 lithium cell. It's a commodity cell, very commonly used in things like flashlights. Pretty much all your cordless lithium-powered power tools use the 18650. My Tesla Model S, which is I'm filming in the trunk of my Tesla Model S right now, uses about 8,500 of these lithium cells. Exactly the same form factor, though made by Panasonic, soon to be made in Tesla's own battery factory. But anyways, 1, 2, 3, 4, 5. Now, fully charged, each of those cells is 4.2 volts. That's absolute top voltage that you want to put in one of them. So, let's take 4.2 times 5, and that should be 21 volts. However, the way they have it wired, they have these in a series. We don't get that for some reason, which I think is a little bit deceiving. Now, I did go through and check 4.14, 4.13, 4.14, 4.14, and 4.15. So that's pretty darn close. So all these cells are pretty well balanced between each other. But it's how they're put in a series determines what the output voltage is. So obviously you take, if these were all in a series, it would equal 21 volts, which would then give you the advertised voltage that you're supposed to be getting. But for some reason, this pack, the way it is wired, is only putting out 10.2 volts. Now, like I said, I use this slightly after taking it off the charger. You don't leave. The best is to leave a lithium cell stored at 50%. Obviously, I want to have some power in it when I need to use the vacuum. So I just run it for about a minute and do a little bit of touch up. But basically, how the pack is wired determines the voltage. And the way this pack is wired, it makes no sense. They have, I'm looking at the contacts here, I don't want to take off the protective padding because that's also keeping the terminals from touching anything metallic. Don't want any shorting out, especially on a lithium cell. But the way they have it, they have these two in a series, or these two are in parallel, and that one is just by itself in a series, the way it's wired in there. I know it's a little hard to see on the camera, which makes no sense because that means this cell is going to drain out quicker than the rest of these, causing low voltage and the vacuum to shut off. That one plus this one's going to end up wearing out quicker. The way they have it, it really should have had one more battery to make it 6. This is just strange. I don't know if they did this pack wrong. I did notice when I used this battery, it might be something that someone screwed up the manufacturer of this battery. Because when I use, my mom's got the same vacuum. When I use hers, a battery from hers, my vacuum cleaner runs noticeably higher power, or louder, more suction, so on and so forth, which leads me to believe, and she uses hers considerably more, so her batteries are quite a bit worn out. I didn't get a chance to test the voltage on hers, but it's just, it's very strange how they have it set up, because technically, 4.2, 4.2, and 4.2, so you take 4.2, which is the top voltage, times 3 then, is 12.6, not too far off, so just about what it would read, approximately if these were still all fully charged, at least theoretically. So there's some funkiness going on with these batteries. And like I said, I test each one individually, and each one is at proper voltage as I go. So I don't know what to say. One thing I will say is they have some awesome battery balancing circuitry on here to help keep these batteries in top condition. Check that out. There's also a heat sink. There's some. I'm not sure what these are supposed to be, but got some. I don't know if it's a voltage regulator of some sort, don't know, or some sort of cutoff circuit, but you got it. And that's it. Just thought I'd show you that. I just want to talk about the Hoover Lynx cordless vacuum battery. It is supposedly a 30 watt-hour lithium-ion 18-volt battery for the Hoover Lynx lithium-powered vacuum cleaner. Now, first I gotta say, this is one awesome vacuum. It's the best cordless vacuum I've ever used, in which I prefer because it's small enough for my younger son to use when he makes a oopsie. He gets to help clean it up, and he loves vacuuming. And I even wake up in the middle of the night, 4 a.m., and he's out in the hallway vacuuming. Why? I don't know, but he gets that from Granny. Anyways, of course, my vacuum's probably 4 years old now. It's getting a little aged, and battery doesn't quite last as long as it used to. I use it about, really drain it once a week, and then fully charge